Hi guys, and welcome to the type 6 of this series of wire netting using geometry nodes and Blender. So let's get started. Now I'm using the version 3.3.0. Go to plus button here, general and geometry nodes. Shift A to add a mesh. Simple plane is a good selection. Click here to add a new geometry modifier. Let's get started with the concept. Now we need to create a series of horizontal line. This is the simple step. And then we have to create vertical groups of lines. We want to have a sine shape. This is the horizontal line from the side perspective view, avoiding collision and with a random tilting effect along these shapes, maintaining a contact but without collision with the horizontal lines. First of all, we have to use a curve line. We have to resample it with Alt right button drag, instance on point, what? Another curve line, but going in another direction. So we want to create a vertical line and instance an horizontal line on it. So we need to create a curve line with a curve to mesh node, circle curve used as a profile curve, fill caps, shift alt and click. So we want to go to the y axis and not the z axis. We can decrease the radius a little bit. We can export the group input with a combine XYZ here for the end of this horizontal curve line. So we can export these and go to group, renaming width from 0 and use a similar Shift D combine node for the end of the vertical line, exporting the Z value as the height from 0. Perfect. We can export the radius of the profile curve and we can rename it in radius bar if you want. We can export the count of this resample curve so we can get a correct number of horizontal bars. So V counts, vertical counts, because this is the count of this vertical line. We can link these to the point and link these to the instance, and we can link these to the geometry output, and we can see anything. Why? Because we have to set the height of these and the width this. We can decrease the radius bar, and this is the first part. You can select all these nodes, Ctrl J, F2, horizontal lines. Now we need to create the other curves here, making a sine effect on it. So we can create a curve line, get the group input to help our job, use a combine XYZ, use the height for the Z axis and link these to the curve line for the end point. So now we have this vertical line. Shift Alt and click to isolate the selection. We can resample these with the same count exported before. Now we can select these nodes, Ctrl J, F2, single wire, but we have to increase this count if we increase the counts of the vertical lines. Otherwise, we could have a better result of the shape of the sine function. So we can increase these, multiply, for example, by 2. If you want, you can change this value depending on your performance PC. And next, we will change adding another value depending on the tilting of the wires along these curves, because more tilting needs more counts to get a correct result of the final shape. Not now. We need to create a triad of the curves so we can easily transform this geometry. This is the original, this is the transformed geometry. We can use a combine XYZ. For the translation, we need a triad, so we need a curve here, the original, one to the right and one to the left. So we need a couple of these shape, a join geometry to link all these three geometry. We can get the group input again, and you know that we want a radius of a single wire. So we know that the wire on the left needs to be moved by the radius of the single wire multiplied by 2. to get the correct new axis of the curve to the left and the curve to the right. So we can use this y-axis value here, rename it in radius wires from 0. We can multiply these by 2, and if we want the first to the right, we can easily link this value to the y-axis of this node, and 1 multiplied by -1 to get the opposite direction of the other curve. Link this to the y, Shift Alt and click. We have no result because we have to set the radius wires 0.001. For example, we have an issue here because we have to link the same curve here for the transform node, and because we want to have the triad instanced on the horizontal line, we don't want the triads start from here but here, because the horizontal bar starts from here. So we need to shift this entire group of wires a little bit. By what? By 1 radius multiplied by 2 radius, because here we will have 1 wire, here we will have 1 wire, and here we will have other wire. In the tail we will have not 1 wire but 2 wires. Okay, one here is a similar perspective view, tilting themselves here and here and here. So we have to keep in mind that we need this radius and not the entire radius. So we need to think in this way: line, line, line. We have the radius of the wire, the single wire. Okay, this is the radius of the single wire. 1, 2, 3, 4 times for the transform node here and here. So here we need to multiply this new meaning of radius wires by 4, and then we will need to move all these triad of wires by what values? These 4 radius plus other 2 radius, so 6 times the radius of the single wire. 1, 2, 3, 4, 5, 6, to have this point in the 0 position to get the correct position on the horizontal bar. We need to multiply this by 4 to get a correct position of the other wires, and then we need to transform the entire geometry with a combine XYZ link here and use the radius wires multiplied by 6 to the right on the y-axis. We can join it with the Shift right drag button, G to move, and go here. We can select all these nodes, Ctrl J, F2, triad of wires. Now if we want to start to see the final result of this profile curve, we can use the same approach of previous tutorial. So we can get a circle, curve, a transform, group input, link here. We can use combine XYZ for this transform, Shift D these to have the other circle to the other part, a math operation with a multiply value of -1, and we want to link the radius wire here and the radius wire here, join it together, Shift Alt and click to see the result. You can decrease the radius. Here we have to set the multiply value, link the vector to translation and the geometry of the same curve here for this translation. Perfect. The radius is too big to see the result, so we have to decrease, but with what number we can use the radius of the wire, and we can see the final result here. We can hide the annotation. Perfect. If you can see all your viewport meshes, you can go here to view section and decrease the clip start value to see the smallest part of your meshes. Now we can create the curve to mesh to see the result, not the final result, but you can better understand what I'm doing with this tutorial. So sorry, this is correct. Shift and click, and this is the triad of wires. You can see 3 couple of wires here. Now that we have these nodes, we can select all these nodes, Ctrl J, F2, rename it in curve profile. Now we have to instance this shape on our horizontal line, so we can add a curve line. We can resample it using the group input information, so we can export the new counts of the new value width, and we can set these go up, rename in horizontal counts from 1 is perfect. Use a combine XYZ, link these to the end of the curve line, set the width in the y-axis of the combine, and we can instance on point on this curve. We want to instance this triad, use this for the curve profile result. This is the result, but we need to adjust some values, because if we join these original horizontal lines with this instance of wires, so if I press Shift Ctrl right button drag and join it together, you can see this bad result. Shift Z to see the result. We need to adjust the entire width of this horizontal line on which we instantiate the triad, because otherwise we would have the last triad over the horizontal line. So we need to adjust a little bit the width of this line, and to do this we need to go here to the horizontal line, and not using the width, but the width minus this entire length. So this entire length is composed by the radius of this wire multiplied by 2, 4, 6, 8, 10, 12 times. So we can multiply the radius wires multiplied by 12. We can subtract to the width this value and use it for the y length of the entire curve line. Now we have a correct position here and the correct distribution, the middle distribution of the resample curve on this new length of the horizontal curve line. Now this is correct. Select all these nodes, Ctrl J, F2, instances, wires. Now let's make the tilting. Decrease a little bit the radius of this bar. It's not so important, but now I move these because I know that there will be other section between these sections. Now let's make the tilting. We have to set tilt this curve, but before this tilting, let's leave this node here for a moment. We need to have to manipulate the x-axis of these wires to follow the sine mathematical function without collision with the touching on the horizontal bar, but without collision and with an adaptive contact while tilting. So to do this we need a set position, but we have a problem. If I press Shift Ctrl click, we have 10 instances. Okay, Blender doesn't know that they are curves or meshes or other stuff, so it cannot move the points of our curves because there is no points for it. So we need to realize instances to get splines that have control points, and now we can correctly set position. Now I delete Ctrl X this value. We can use the spline parameter, the factor attribute of this parameter, go to multiply, because we will have to set a frequency of this sine function. Then we want a sine function of this output point, a multiply value to get more or less amplitude depending on the radius of the wire. Then link these to the combine XYZ, the x-axis, because we want to shift on the x-axis, the red line, and link this to the offset. Now it's obvious the frequency is wrong. We have to adjust this value and this value. Now we have to increase this frequency. So if I increase this frequency, I need to have this shape, similar shape. I decrease for a moment this amplitude because we need to have a value with shifting here. So we need to add a value here with a math operation. We need an add value of what? We need to shift this value by pi divided by 2 because we won't go between the horizontal line, and we have a similar correct value. You can see now this value has a relationship with the vertical counts. So if I increase the vertical counts, this value needs to be higher, so we can get the correct value decreasing these to 2 points. So you can see this behavior, and now we could get a better result if we set the handle type and set the spline type of this curve to Bezier to see better the shape. Now we want to have the line go from here, go in the center of the axis, and then to the other part. So we have here 2 frequency, so we can increase a little bit this shape, and we have to decrease the frequency. We can set an height number of this single line, maybe 10 for example, and not 2. Now we can decrease or increase a little bit this value. 10 is too much, so we can use 4 or 3 for example. Now we can add a value here. We can notice this. We can use pi value. We have to add pi divided by 2 to get the correct piece of the shape, and now we can multiply the factor before multiplying by this pi value. We can multiply these vertical counts with the factor and multiply these by this number, but we have a problem. We need a multiplication of 1 if we have 2 counts. So we have 2 counts, the multiplication needs 1. If I have 3 points, 1, 2, 3, I have to multiply these by 2, and so on. So we need to decrease these vertical counts by 1 value before the multiplication in this node with the factor. Now if I increase this number, I have the correct shape. Now this strange and weird effect is caused by this set spline type and set handle type, but don't worry, we have to decrease this value and we want to multiply this by what? So we need to multiply by the radius of this horizontal line. So we can easily multiply the radius bar after the sine and we can get this result. Now you can see this weird effect because Blender, when you use in this case a realized instance, if I mute and unmute these realized instances, this rotates all group of this line by 90 degrees. So to fix this, we have to link on the x-axis the translation of the single circle line that we created before to make the correct alignment of this group of lines. Now we can work here. We can mute for a moment this set spline and set handle type because they slow down your PC and your performance for now, and I increase for a moment this first value of count of the single resampled line to have a better result. Next we will use these 2 nodes in the render time, turn it off in the viewport time. So we will use the is viewport node to switch. Now that we have these, got 1, you can see Shift Z to see the wireframe result. We have to add the radius wire to the radius bar to get the correct value of this amplitude after the output of the sine function. So we can select this node, Shift D, click, link the radius bar, link the radius wires and use it to the multiply, and this is the correct result. Now if I increase to 20 or 40 vertical counts, you can see the correct result. Shift Z to see the mesh. Now we have to alternate the shape, so one in this direction, one in this direction, one in this direction, and so on. To alternate these, we need a very important information, the index of the single spline. Now if I Shift Alt and click, you can see the entire triad of the wires goes in the same direction, and I want to alternate the value of the sine function between two lines. So to do this, I need the index of what? So now if I use this index and multiply it using the module each2, and I can use a map range. If I have a 0, I want -1, and if I have 1, I want 1. So I can control the sign of the result, and I can multiply this value by this output of the sine. So if I multiply this value by this result and use it for the x-axis, I have this weird effect. Why? Because after realize instances, I have the control points, so the index attribute get by this workflow going back, we have the index of the single point of each spline, and we don't want that. We want to have the index of the single line independently. So 0, 1, 2, 3, 4, 5, 6, and so on. And to get these, we have to use the fantastic node, I think, that is interpolate domain. So we can set these, and we want to have an integer value of each spline, and it will use these, transferring that index to all the points here. So going back, the workflow will get the index of the spline for each point, control point of each lines, and use it for the purpose we want. So now we can set these to the module, and we can have the correct index of each spline using it in the module node, and then for the map range, and then for the multiply, and then combine XYZ and so on. But there is a little issue that we can easily fix. You can see one line goes in one direction and the other lines to the other. If we want to invert this situation, this means that the number of index of these is not 0, 1, 2, but maybe 0, 1, 2 or 0, 1, 2, for example. So to fix this, we need to go to the triad of wires and change the correct order of adding here in the join geometry. So you can see the original is here, the positive translated curve is here, is the first, and the negative is in the second position. So we can adjust these to get the correct result. So I need to have the first here, next the original, and next the negative, for example, to get a number of 0, 1, 2 in this case. And now we have a correct alternate value, two wires in this direction and one in the other, one in this direction and the other to the other direction of the axis. Now we can Shift Alt and click to the join geometry to see the complete work. Press 1 is not finished because we need to talk about the tilting. So we can select all these nodes, Ctrl J, F2, make sine shape of wires. Let's make a better layout here. Now let's talk to tilting. It's the last and more tricky part of this tutorial. So we need to tilt our wires. So we need more space between the instances of the wires and the making of the sine shape. Move these a little bit. Alt P to have the node separated from the previous section, and now we have to set the tilting. Now the tilting, we have to add a group input as before, as the previous tutorial, and we can use a math operation to multiply what? A value of tilt radius. We can export a value as the tilt rounds from 0 multiplied by a value and use it for the tilting. And remember that we have to multiply by pi multiplied by 2 to have one round in radians here. So if the tilt round is 1, we have 6.283 radians used in the tilt attribute. Now if I have 0, I have 0 here, and now if I set this to multiply and increase this number, you can see I have one entire round if I increase this value from 0 to 1. Now that we know this part, we can realize before this value in this tilt section, Alt P to separate this from the other sections here and make it better. We can select these two nodes and move it before the tilting, because we know that if we tilt these values we need more count in the making of the resample curve node. So we can realize instances, select these, and then set tilting. To get a better performance we can use an is viewport node and use it in a switch node. This is the node when we want in a viewport environment the original geometry output, and if we have a render environment we want the set spline type and set handle to get more complex mesh to the final render. So we can switch these a little bit. Now we keep in mind that if I set this tilt round in this value, I have the tilting for all the points of the curve at the same time with the same value. Now to have a different value of tilting for each point on the curve, I need to use the spline parameter, and I have to use the factor, so from 0 to 1 multiplied by the tilt round and then this value multiplied by this value here. And now we have a correct tilting distribution between all the points of the curve. If I set this to 0.2 in height and decrease to 10, we can see the result. I can decrease for a moment 0.3 and 5 count to have better performance. Now you can see I have one tilt round. I set 0 for a moment, go 1 to the front orthographic view, and you can see this particular effect. I decrease a little bit the count, perfect, and you can see if I turn it to 1, I have this particular effect. I have correct value of contact, but here there is a problem. Shift Z to see the result. If I increase or decrease the tilting, I have a collision here. So I want to avoid this. I know this information. When the value of the tilting of each point calculated through a sine value has 0 as the result, I want the original value of the amplitude. But if the sine of the tilting value of each point calculated by a sine function is with an absolute number, a value of 1, so the highest value I can get from it, I want to have not the original value but the original value plus a single radius of the wire. I explain this. If I go in the make sine shape of wires section here, you can see we used these radius bar and radius wires added to themselves, used with a multiply value here with a sine value to get this distance. So this radius plus this radius multiplied by the maximum value of the sine function, so 1. We have to transform this add with a map range. So we can use a map range and we can use it in this way. We can get the tilt value of each point, and when the tilt value in a sine mathematical function has a value from 0 and 1, we have to adjust this value to min and to max to use in this multiply value of the offset of this set position. Now, the minimum value we want is the radius bar. It's obvious, always we have this. So we can leave the correct radius bar here, but link these to the multiply, okay, and add not a single value of radius wires, because if I have these, I have this here, but I have this weird effect here, but I want to have as the minimum output value of this map range when we have no tilting of each point. This is the first point, we have no tilt here, so we want the radius bar adding a single radius wire, and this is the result. Don't be afraid for this because the 2 max is very high, so if I set this to 0 you can see the correct result of before. So if I link these, nothing happens here in the first point because there is no tilting, zero tilting in the first point because the factor of this line starts from 0. If I link these, now we have to adjust this value by what? You can see perfect number here, so we can use the radius wires multiplied by 2. So we want multiplied by 2 this value. Now you can see a correct workflow, and we have only one value of the radius wire here and 2 times here when the tilting is in the maximum values. And if I go up, we have this value here, and there is a problem. Why this behavior? Why this value? Because here I have the tilting go up, okay, and the sign of the positive number has a positive number, but next the sign has a negative number. So we need to adjust the sign of the result of the sine function. So we don't need negative number because we have a map range from 0 to 1. So we need to use an absolute value here and use this in the value. So we have only value from 0 to 1 and not negative numbers. And now if I go up, I get the correct values. If I increase the number of radius, you can see the correct touching behavior in our environment. Shift Z. Now we can select these nodes, Ctrl J, F2, tilting. We can make the tilting better because if I go to 3, right of orthographic view, all the lines have the same tilting. It's not realistic, so we can get a random tilting of each lines. How? It's easy. You can easily add a value on our tilting values here. So we have here the general tilting of every curves we created, and we can easily add a value depending on the index of our interpolated domain with an integer. It's correct, the index is an integer number, but for every spline. So we can have a different index value for each spline and use it to add a random value. This is not a min, we have to use a float number, and this is used as the ID to get a different number of random, and we need to use a different min and max value. So we can use the result of this starting value of this point, divide by 2, for example, and this will be the factor you want to use as the standard deviation. So is the range that you can get a new random value to add to the original and general values of the tilting. So we can use this in max value and use these multiplied by -1 to have the min value. This is the max and this is the min. Use it in addition with the original value here. This is the result. We have the interpolated value here, the index, and you can use it as the tilting you want. And this is the result. We have a little shifting of tilting for each spline, so it is more realistic. If I have 20 rounds, you can see it is in a small piece of shape of curves, so don't worry for this bad result, because for the viewport this is a bad result, but in rendering time you will have a good result thanks to this little portion of nodes. Now we can set these to an height number, so 10, 1, 10 for example. We can decrease this number, so 5, radius bar, or 3. And now for the final step, we can assign the material we want. Set material for the wires, Shift D, and set material for the bars. We can create a gold material, yellow, not all saturated, all metallic, 0.05 as the value of the roughness. Select these, gold, and add a new material, new, steel, roughness 0.05, all material, and select it to the steel. Go in the geometry nodes, in the material preview, and we can go here, select EV, select the result here, go to the environment, select color, environment texture, open and select your source image of the HDR, set a strength you want, go in the render properties, under film, make it transparent, color management, not filmic but standard for this tutorial. Let's tweak the material of the gold, more orange, and to layout, select focus, select the rendering value, and you can make it as you want. You can decrease or increase your environment, the width you want, change the counts of your horizontal bars, the counts of the vertical groups of wires, increase the radius bar, avoiding always the collision between the groups of the wires and the bar, even if you set the tilting value here, change the radius of the wire you want, and you can see no issues even if you change the tilting values. And this is the final result of the tutorial. Thank you guys for watching this video. I hope you like it. I hope you like the entire series of this tutorial. If you like, you can check a like or leave a comment if you want. Remember that you can download the project of this tutorial from my Gumroad page, or download the entire bundle at the end of this series. If you like what I'm doing, please subscribe to my channel. If you have subscribed, make sure to check out the bell icon to get notifications of all new posted videos, and see you in the 7th type of wire netting. Bye!